All right, so yin and yang of coding. Okay, before I start, I'm Satish Gupta. I'm here to share some interesting insights and learning we had over the last couple of years while building some amazing products at Content Stack. So let's get started. Yin and yang. So this is Taoism is an ancient Chinese. I'm sorry, am I too loud? Okay, yeah, okay. Okay, so Taoism is an ancient Chinese culture and philosophy known for a unique uh, philosophy or thinking. Taoism believes that they perceive the universe as a form of energy and waves. Yin and yang representing the dualistic nature of universe and everything inside it, right? So yin and yang being the complementary forces that maintain a state of dynamic equilibrium. So that's about yin and yang. So what is yin and yang in coding? Any guesses so far? My teammates are not allowed to shout. They know what it is. So yeah. Before I actually talk about this amazing thing, I want us to take a few steps back, and I want to question some fundamental things about why we are here or why are we discussing. Like Mayank mentioned, that we want to build great things, right? Why do we want to do that? Why do we want to build better software? We want to stay competitive in this industry. Without this zest to create a better software, we are nothing. We'll perish. We'll perish like anything. So what do we do, right? There's something that I'll be talking about that is gaining traction in the industry recently, and it is called DORA metrics. So DORA stands for DevOps Research and Assessment. DevOps was a team that set out to answer a fundamental question in 2014. It was just one question, but they really rocked the industry. The question was why some teams are performing way better than other teams. Why is that so? In the quest of answering that question, they have done massive surveys over the last 10 years. Their surveys span globally. Their surveys have 26% elite developer teams. More than that, they published a yearly report stating some important know-hows or metrics to follow or to chase if you want to build better software. So what are those metrics? There are 4 primary metrics that DORA talks about: deployment frequency, load time to change failure rate, and mean time to recovery. While I have stated the primary purpose right after the metric, and also what do we need to do to do better in terms of that metric. So I'll be following through each one by one. So deployment frequency is basically trying to answer how frequently do you do your deployments, how frequently do you take your changes to production. And lead time to change is basically the time taken from a commit to production is the lead time to change. The top 2 metrics are velocity metrics. They basically keep the development velocity in check, while the later 2 are stability metrics. They tell us how stable our software or our processes are that enable us to build a stable software. So to the right, I've jotted down some points that helps us move closer or do better in that metric. I'll quickly go follow them one by one. So to do better in terms of deployment frequency, what you need to do is you need to ship faster, you need to ship smaller, and you have to automate as much as possible. Why do you need to do that? When you do that, you are basically saying, am I allowed to push merge my changes? Am I allowed to do release frequently? Am I allowed to sync my changes with my teammates frequently? That enables me to check if my changes have any issues daily, frequently, and uh, for multiple times in a day. Moving forward to the second metric, which is lead time to change, we basically do shift left. That has been our mindset for last few years. We are shifting left in terms of development process, requirements, design, security, and everything that helps us build better software. We also have some steps that require you to do better in terms of lead time to change. Are you also automate your tests, you eliminate bottlenecks, you eliminate phases that do not allow you to release your software frequently. All these metrics are somehow interconnected. When you talk about them, lead time to change impacts MTTR a lot, and vice versa as well. So you'll find me repeating some things out of them, is because there is a common ground between these metrics, and the relation between the two. Moving forward to the other two metrics is basically change failure rate. Your testing strategy has a huge role to play in that. The better your testing strategy, the lesser are the chances of your changes going into production and failing later on. So that's there. Then there's mean time to recovery. So that basically has two major things that you should be thinking about when you are trying to fix this metric. Is the first one is feature flag. The second one being having observability and good monitoring on your system. So now that I've talked about some action points or some key things that you have to, practices that you need to follow to do better or to build better software faster, do you think there is an issue on the items that I've mentioned or listed to the right? Can anybody guess? We actually went ahead and did all of that I've listed here, and we actually ran into some issues. Can anybody guess? Okay, no one. All right. So let's imagine then. Okay, let's say we decide that we want to build better software. We will first start by attacking a deployment frequency. We'll fix it, and then we'll move on to the next metrics. So let's fix deployment frequency. What do we need to do? So I need to ship smaller commits. I need to ship faster, and I need to automate as much as possible. Let's say I and everybody in my team are committed to doing that. We start making small commits, and everybody is making small commits and raising PR. Okay. As soon as we do that, a couple of hours later, we all are frustrated. You know why? Because our commits, our PRs are piling up. We have a pile up of PRs. So what happened here? I committed that I want to do small changes. So I did. I raised a PR and notified my my teammates that you want to review this PR. My teammates, on the other hand, see this PR, they get the notification. Now they want to context switch with whatever they were doing to gain maximum context to review the PR efficiently and provide feedbacks if possible, as soon as possible, right? The sooner, the faster, tight feedback loops. Yeah. So they do that. Everybody does that. But I'm making commits at a faster rate because I'm making smaller commits. So my PRs are piling up, and I have a backlog of PRs to review from my teammates. So what do we do now? So I guess we have got the issue, right? There's when you follow these things, there is you run into this trap of a big pile of PRs waiting to be merged. We can't achieve deployment frequency metric moving forward. So the velocity metrics is what I'll be targeting mostly, because the technique, the yin yang of coding will be mostly trying to solve around velocity metrics. Obviously, it does focuses on stability metrics as well, but a larger focus will be on the velocity ones. Moving forward to lead time to change. So let's say we want to fix this metric. We identify what do we need to do. So to fix this metric. So let's say on a regular day, I pick up a bug and I start working on it. I fix the bug and I move the bug to QA. What happens next? The ticket is either awaiting for someone to pick up and QA, or it is being immediately picked up by someone in QA. Let's say it is immediately being picked up on, and the QA finds some issues. The issues are relayed to me. I work on them, and I again move the ticket back to QA, and the cycle goes on. It may not happen as frequently as for all the bugs, but it may happen. What if there are more number of bugs? What if there are more tasks in the system apart from this bug that are blocking my bug to be QA'd or to be picked up as soon as possible? So I think we have identified a snag in the SDLC process. The snag being a separate QA step. This separate QA step hinders my ability to make frequent changes or make frequent releases to production. Every time I do a fix, I have to move the ticket to QA, move to something else, only to find after some time that there's a feedback lying around, context switch again, and work on it, and the cycle goes on. So these are the major problems that we encountered, and the yin yang or the technique that I'll be talking about is an approach to solve these problems. So what is that? Pair programming. Okay, I was expecting a lot of surprise expressions, but that's all right. Okay, so how do we fix these problems with pair programming? Before we jump into that, let's talk about pair programming. What is pair programming? I think the best definition that I've encountered for pair programming is on Wikipedia. Wikipedia says pair programming is a web development technique where two developers sit on one workstation, where one is a driver and the other developer is the navigator, right? And the last sentence being the most important one, they switch roles frequently. So that's pair programming in a nutshell. We have been practicing pair programming for, I would say, almost a couple of years recently, and personally for me it has been liberating. I was very anxious, and I had mixed feelings about it. What if I screw up in front of someone? What if I don't go along? What if blah blah and whatnot? But it has been the other way for everyone in the team. So let's talk about what are some benefits or the deal with pair programming. So this is pretty obvious when you find someone talking on pair programming. These are the things that you'll find them talking about. They'll talk about how there are no information silos, how there is no thing called as KT or handoffs in the team, how onboarding is easier, how they are solving bugs in a very short span of time, and whatnot. And the major benefit being team bonding. I mean, I'm not sure if that is on the list, but yeah, strengthen as a team. Yeah, it is on the list. So that has been something that I've experienced personally. Yeah. So how does pair programming solve these problems, right? So we saw the metrics. We know what the metrics are supposed to tell us, and we also remember the problems. The problems being my PRs being piling up, and QA or any step that is causing a snag in making me frequent releases to production. So how do we fix that? For deployment frequency, we ensure that each commit is deployment ready and does the work. So what do we mean by that? So when I'm pairing with someone, when I'm coding, my code is being live reviewed by the navigator, right? So instead of waiting for hours or days for my PR to be reviewed and receive a feedback, I'm receiving feedback in real time. How amazing is that, right? So that is something that enables us to decrease or fix the clog in the PR backlog, and we are able to do increase deployment frequency for our services. Moving to lead time to change. So as I mentioned that we identified there's an additional step, right? The QA step. And to explain to that point, I want to share an interesting story. So we had this a story that was supposed to that conveyed that we want to change our CDN provider. It was a very big story in the first place. It requires tremendous amount of effort and QA on a larger scale. So how did we did it? We paired this one out. So while we were pairing, any changes that were pushed along were I'm sorry, were QA'd at the moment they were merged on the dev environment. So it is as good as real-time QA. The QA step is not waiting for my story to be completed at near point in time, because we knew this story would take months to complete. It was changing our CDN provider. We were not just implementing some API or design or anything. We were changing our CDN provider. So we did real-time QA, and yes, fortunately there has been almost, I won't say that there were no issues. It is not good to say that in software industry. There were very minimal issues when we moved to production with the new CDN provider. Moving forward, so no review code is required as the code is reviewed in real time. I'm not asserting that we abolished pull request. We still do pull request, but the pull requests are faster because the navigator has complete context on the implementation so far. He does not have to go ahead, gain context, talk to me, because he was already talking to me through and through, and try and figure out issues. Any issues that were found were fixed in real time, and here we are. So we were able to improve this metric. I'd like to jump to MTTR. So for MTTR, we use some. I talked about feature flags, right? So I'm sorry. Yeah. So I'll jump to MTTR. So we talked something about feature flags in one of the earlier slides. What we did was, when we moved to a new CDN provider, we did not want it to break the existing change. Obviously, we weren't when it comes to this service, we weren't multi CDN yet. So we had to put some flags in place so that we don't accidentally switch to the new CDN or use the older CDN when not required. So we used feature flags, and anytime an issue occurred, we just switched this flag, and the service wasn't affected. We patched the bug, we merged it, we switched back the flag again, thus having a good stance when it comes to MTTR. Yep. So I'll before I actually talk more about pair programming, I want to bust some myths about pair programming. Whenever we talk about pair programming, people usually go like, hey, it's not efficient. Why should I put two people to do the task of one, etc., etc. It's all a myth. I have sufficient resources. I'll be posting them in Engineering Excellence channel after this talk. There has been substantial research saying I'm sorry, saying that pair programming improves efficiency, it decreases information silos, and it also increases team strength. As everything that I talked about in the recent slide, as advantages of the pair programming technique. So I found this interesting meme. I tend to remember this when I was actually new to pair programming. I was anxious. What if I do it wrong? What if they think I'm a bad programmer? That will be the case for I think most of who hasn't done pair programming would relate. And believe me, it is not like that. As soon as you jump into this technique, you the returns are immeasurable. It is just amazing. Everybody, we are developers, we are humans. To err is to human. We make mistakes. The point of pair programming is to rectify them there and there itself. Yeah. So yin yang of coding. Yang being the driver who is supposed to implement, drive, or actually make the changes, and yin being the navigator who is responsible to direct, guide, provide real-time feedback to the driver. And this harmony will help us build better software faster. Thank you. Any questions before we close?
Okay, Satish, so we have a question from in the chat. Assuming solo programming has a speed factor 1, does pair programming has a speed of 1.5, 2, or 3? Essentially, the speed of pair programming.
That's an interesting question. I like how you measure velocity when it comes to programming. That's not how we do it. So it is beyond my understanding. How do you measure speed in software development? So I'm not sure if it is 1.5x or not, but I'll be posting some interesting links that you should read. They are research published by Dora Metrics and Google and many people who have researched on pair programming and found out to be a better alternative to solo programming. Yeah.
Yeah, Satish, I just want to add on that. So the challenges that you face, right? It's like there was a backlog of PR because you guys were shipping faster.
Yeah.
And then given there is a big backlog, so it could possibly affect the quality of the PRs. Like you may wanna, let's say, quickly say, "Chalo ho gaya, fatafat karte."
Right.
That could happen because it's manual work. So,
that would happen after 5 p.m. Is what I think.
Yeah. So coming back to that question, like, so basically your velocity was affected. That means if you look at your cycle time, lead time data, that would be different before pair programming.
Exactly.
And also the quality data, that is also, it depends. Okay. But after pair programming, I think in this case, right, we would see better cycle time, lead time to commit, deploy metrics.
Yeah.
So that I think that's like one of the ways to
look at it. Yeah,
this.
Definitely. I mean, so pair programming does increase velocity.
Satish, well, good presentation. Very, very good. I have one question actually, pair programming. It's basically, isn't it the fact that the right hand is coding and the left hand is checking?
I'm sorry, Vasu, can you repeat that?
The right hand is coding, and the left hand is reviewing.
Yeah.
It's the same person reviewing then, because both of them technically coded actually.
Yeah.
So the same person is reviewing his own code actually, their own code. How is that review actually? Usually review for me is an independent review so that another angle is looked at
Right.
trying to understand. But if I was part of the thought process right from the beginning,
Yeah.
and the two people were in the same path, and the same person is then reviewing it also, how is that proper review then actually?
Yeah. So to fix that, you can obviously we QA every time a feature is merged. We do a QA. We have automated sanities in place to check. Apart from that, there's something that we also did that I haven't talked here, is that we require 2 approvers for our pull requests. So there's a third person as well who's involved here. I did not talk about it being the tangent to this topic, but we do that for our team. Yeah. Yeah. That way we ensure that there is no biased thinking or biased implementation when it comes to a feature. We always have an extra pair of eyeballs to look at it, just to ensure that whatever is getting merged is right and does what it is supposed to do.
Yeah, and the one way to look at this is, I think in your case, Yin and Yang, right? Both
Yeah.
of them have different sorry. Yeah. Both of them have different intent there, as in the, let's say the right hand, right? That's more focused on being having that reviewer glasses, right?
Yeah.
She's wearing that. And someone who's writing the code. I think that is a way to just balance that out.
Yeah, that is how we do it. Whenever we are pairing, one of us, the navigator, will put on a QA hat,
Right.
the driver will put the developer hat, and we are checking the implementation in real time. We are suggesting. We at times we also go out and discuss when we are not satisfied with the implementation. We bring in a third one from the team just to take a look at it and to make sure what we are putting in is the right way of doing it. Yeah.
I think it would be awesome to have AI as a pair programmer. So, anyways, yeah, thanks, Satish. That
Yeah.
was awesome session.
Thank you. Yep.
Thanks, Satish.